Hey guys, so we made this thing called ZkDAI. It's called Zero Knowledge DAI for ETHSingapore, and it lets you do private transactions on Ethereum. So when I say private, it means you wouldn't know, a third party wouldn't know the value that you transferred to a recipient. Also, the third party wouldn't know the recipient themselves. So yeah, these transactions would be obfuscated, and it's very similar to how Zcash works. So the flow here is you come to a DApp, right? Whatever tokens you might have, you use Kyberswap to swap them to some DAI, and then generate a zero knowledge DAI, which is like a secret note on chain. And then you can keep transacting with these notes. You could keep sending them to people. Also, when the time comes, you can liquidate these notes to the vanilla public DAI, right? And we have the functionality for that as well. And whatever the value of that secret note is, you'll get the equivalent amount of DAI in your account. So, or you can send it to someone. So how it works is we represent a node by a public key and the value of that node, right? But what we save on chain is the hash of that node. So only you know what the values here were, and no one else knows about the node, who the owner is and what the value is. Now when you want to transfer this node, you have to prove that you own it. And how you do that? You prove that you know the secret key that corresponds to this PK, right? So this node belongs to you. And you also claim note of the value to be something, right? And you produce a zero knowledge proof of the fact that you know the hash of this node which is on chain. And if the zero knowledge proof verifies, it means that the node belongs to you and you can transfer it. And how you transfer it is like UTXOs, like in Bitcoin. So you generate a new node, and let's say you want to send some value V dash to the receiver. So you generate a new node with the receiver public key, comma the V dash value, and another node which goes back to you again, and it's like the change left over from your transaction. So the value here is V minus V dash, right? And then you send the hashed version of these nodes on chain to do the transaction. Now I'm going to walk you through a demo. So we have already deployed our contract on Robson, and I'm going to log in with MetaMask now, right? And I'm going to transfer some Ether for some DAI tokens. So the exchange rate here is 11.8. I'm just going to increase the gas. Cool. So what will happen now is your DAI will be transferred to our contract, and subsequently another transaction would be generated where an encrypted version or the hashed version of your node would be saved on chain. Yeah, just waiting for it to come to the UI. So this is a transaction that is generating the secret node, and this is where the 11 DAI were transferred to my contract. Cool. So yeah, when this gets confirmed, you would have the node on chain. Ideally this could be a single transaction, but for the sake of the hackathon, this is how it works. Yeah, cool. So now I'm gonna refresh the page, close this, and refresh my account. So this is your node, and the hash is saved on chain, which means no one knows about the value of this one, but you do, right? And then the status is created, and the amount here is 11. To a random viewer, this looks like a random bunch of hash here, so they don't really know what it is. Now I'm gonna try to transfer this node. Now that involves generating a zero knowledge proof. And so yeah, before I do this, I have a script ready which will give me all the params for this zero knowledge proof. And what it does is, so it's called ZkCNT, and what it does is I say I am the sender, I want to send a value of 11. Like I own a note of value 11 and I want to send a note of value 9 to this receiver, right? And it'll give me the CLI params for the Socrates library, which is quite experimental, and that's why we're using the CLI for now. Right, so I'm going to run this script. So these are my Socrates params, and I'm going to go inside the container to generate this proof, which takes quite a while. So I'm generating the witness right now, which means I'm claiming that I know what the values behind the hashed nodes are. And after this, I'll generate a proof of this node, which will go on chain. So Socrates generate proof. And when this will get generated, I'll copy it to my scripts folder from inside the Socrates container. So yeah, from my Socrates container to my scripts folder. Yeah, so this has been generated, right? And this is what a proof looks like. Now I have it right here. Now I'm going to run a script called transfer node, and that is quite complex in itself, and that's why it's a script. So what it does is it sends the proof on chain along with the encrypted versions of the two new nodes. Cool. You can check this file out in our GitHub repo. So I'm gonna run the script now. So this is a proof that is going on chain, and these are the two new hashed versions of the nodes, which will be visible to all. Now if I go back to my contract, I can actually see the transactions if they have been picked up as yet. Yeah, it has been. So this is a transaction, and the input data here is like bunch of gibberish. No one can make any sense of it. It's actually the zero knowledge proof, but it doesn't mean anything to a third party. Okay, so the transaction has been confirmed, and now I'm going to refresh my account to see what I have. So my note worth 11 has been spent. I have a new note which is of value 2, and let's check out the recipient. So this is another account in my MetaMask whom I sent the note to, and yes, I have the value of note 9 here transferred to me, and this is a bunch of cache pool and like all the hash nodes which no one knows about. Now what I'm gonna do is now this is a secret node on chain, right? Not really DAI that I can spend on chain. So I'm going to claim my DAI, which means I'll convert my secret node to vanilla DAI, which I can actually spend. So this is my contract here, and this is a transaction that will actually transfer the DAI from the contract to my account. Well, the transaction is confirmed, but ETHScan takes a little time to pick it up. So transaction from to the contract, from the contract to the recipient here who tried to claim the note, and well, here it is. So I can actually check the transaction here. So I was transferred 9 DAI right now from the contract. So yeah, this is the demo for our project, and we hope you like it. Thank you.